And notice they are ordered by their indices. Well, dictionaries have a different kind of ordering because what they are really just a list of mappings. So here we have a dictionary of singers, and Iggy Azalea is mapped to Fancy, and Beyonce is mapped to Flawless, and Adam Levine is mapped to Maps. So here we have singers mapped to their songs. But in a list, there's no such thing as a mapping because all we have are the elements. But you could think of them as a mapping of an element to their index because if you know, if you remember that indices in lists are 0 starting. 0 is mapped to 0, 1 is mapped to 1, 2 is mapped to 2, and 3 is mapped to 3. So lists don't really have mappings, but they do have these orderings. So we can think of the first element being mapped to the number 1, and the second element mapped to number 2, and so on and so forth. Alright, so just a little bit about syntax working with dictionaries. Dictionaries always start with these curly braces, which distinguish them from lists. And when you want to make a mapping, you would put the key first, and then a colon, and the value. So this is the key, and this is the value. Right. And you can have as many as you want in a dictionary, but every key must be unique. All right, so moving on. In this example, if we were to try to find Beyonce song, we might access the dictionary like this. So singers bracket Beyonce. So it's similar to lists, except that instead of putting the index that you would access into at the list, you would put the key instead, because in dictionaries we work with keys, not indices. So when you pass in Beyonce, you get back Flawless, because that's the song that she's mapped to. And likewise, you have Iggy Azalea mapped to Fancy. So when you pass in Iggy Azalea as a key, you get back Fancy. All right. And you might want to do other operations, such as update an entry for an existing key. So let's say Beyonce comes out with a new song, Survivor. So you can set Beyonce inside this dictionary to Survivor. So that is the syntax for it. And now when we call singers a Beyonce, Beyonce's value is Survivor, no longer Flawless. All right. And then if you want to make a new entry after you've already made the dictionary, you can still do that by doing the same syntax as you would with updating a key. So updating key equals new key in terms of syntax. So it's exactly the same, but the functionality is different. So in this example with Nicki Minaj, oh my gosh, I can't talk today. We add Nicki Minaj as a key, and she's mapped to Anaconda. But notice we didn't have Nicki Minaj in the first place, so this is a totally new mapping. And in this case, we're not updating anything, we're just adding a new pair. All right, and another useful thing is that you can check for membership of keys. So what that really means is that if we wanted to see whether something was a key in our dictionary, we could say, for example, Adam Levine and singers, and it will tell us whether it's actually a key or not. So if we wanted to know, like let's say, is Lizzo in singers, then it would return false. So if you also want to iterate through a dictionary, remember that in a list context, you can do something like for each in A, and then print each. And this will print out every single element. But if you do this with a dictionary, it does something slightly different. So if you do for each in shopping cart, where shopping cart is a dictionary, and you print out what each is, it's going to print out apple, bananas, and orange. So notice here that you're only printing the keys. And that's because by default, when you iterate through a dictionary with something like for each and shopping cart, that will iterate through the keys instead of something else you might think, like the pairs or the items. But you can do something else, which is say for each and shopping cart, print shopping cart, bracket each. So what this is going to do is give the temporary name each to every key in the dictionary. So at some point, apple will be key, bananas, orange will be each. And then it's going to say shopping cart of each, which at some point will be 3, will be 4, and will be 6. So it's going to take that key and use it to access the dictionary. And that's how you get the values iterating through the dictionary. All right, this is just like a little hack to iterate over the values instead of the keys. All right, so moving on to question 4, we have a very nifty function called counter, and it's going to take in a string of words and return a dictionary where each key is a word in the message and each value is the number of times that word is present in the original string. So this question is really interesting because this sort of function appears a lot in data science. For example, in Data 8, you might have had seen a function where it takes in the text of like Mark Twain and then counts up all the words and the times a certain word appears. So like maybe, I don't know, the word I appears like 1,000 times or something like that, and the word the appears like 200,000 times or something like that. These are totally not realistic, but it's a very interesting function because you can pass in any text, like a book, your favorite article or something like that, and return to you the distribution of words in that text. So a dictionary is really perfect for this because here we have the natural pairing of word to the number of times it appears in the text. So what you want to do is iterate through that text. In this case, it's going to be message. And then every single time you see that word, you update your dictionary or add it to your dictionary as a new pair. And remember that we have some syntax that we went over to add a new key, new, or update. And remember that it's totally the same, exactly the same. But in this question, you want to make sure that you check whether or not it's already in the dictionary, because if it's not, you want to add it, but you might want to do something else if it's already in the dictionary. So let's say I've already seen the word I, and it's mapped to 1 because I've seen it one time. So I'm going to change this to 2 if I see it again. But let's say I didn't see I, so it's just not in my dictionary. So I'm going to have to, add the pairing I mapped to 2, I mapped to 1 because I'm just seeing it for the first time. So these are going to be your 2 cases that you have to think about for this function. All right. And moving on to our last question that we're going to walk through or talk about in this video is replace all. So given a dictionary D, we want you to return a new dictionary where all occurrences of X as a value, so not key, is going to be replaced with Y. So in this example, we have foo of 2, bar 3, garply 3, and then XY, ZZY 99. So it's going to replace all of D with with poof if it ever sees a 3. So we're going to expect that this should be changed and this should be changed because they both have the value of 3. And if we look here where it checks to see if e is equal to this result, we can see that it returns true, and it returns true saying that bar has been changed to the value poof and garply has also been changed to the value poof. So the idea behind this question is that you're going to iterate through the dictionary and check whether the value of this key is equal to x, and if it is, you're going to change it to y. Okay. So that's it for this walkthrough video. I hope you found it helpful, and I hope it gave you some running start for tackling some of the problems on this lab.